Hello and welcome to Maths with Jacob. This lesson will focus on equations with indices. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. You will have an opportunity to subscribe to my channel at the end of the video. You can subscribe at any time on my channel page. You are also invited to share this video with your friends. Thank you in anticipation. Equations with indices. At times we have an equation where an unknown variable is part of the index. For example, 4 to the x equals 64. It can be easily seen that x equals 3. However, some examples need a little extra work to find the answer. And here's example 1. 3 to the power of y plus 2 equals 81. Now, the trick here is to try and get 81 as a power of 3. And we can, because 81 is 3 to the power of 4. So see here, each base is 3. So all we do, we just let the indices equal one another. So y plus 2 equals 4, so y equals 2, and that's the answer. That's quite a simple example, but it gives you a very good idea how to proceed. Example 2. 8 to the power of x plus 4 equals 256. Now this one's a slightly more involved, but look at the trick here. Can you see how 8 is 2 cubed? So that's 2 to the power of 3 outside of x plus 4, so that left-hand side is finished. Now if we can write 256 as a power of 2, that's exactly what we want, and we can because it's 2 to the power of 8. Since both of the bases are the same, you can let the indices equal each other. So 3 outside of x plus 4 equals 8, 3x plus 12 equals 8. If we subtract 12 from both sides, we get to here. Some simplification gets us to here. Divide both sides by 3, and there is our answer. Third example, slightly more involved. 25 to the power of x plus 2 equals 1 over 625. Now, let's see if we can get 25, for example, with 5 as the base. And we can, because 5 squared gives us 25. So it's 5 to the power of 2 outside of x plus 2. Now, we know that 625 is 5 to the power of 4. Now the next line, so the left-hand side stays the same, but 1 over 5 to the power of 4 is 5 to the power of minus 4. So now we let the indices equal each other, so 2 outside of x plus 2 equals minus 4. And we get rid of the grouping symbols to go to that line. Subtract 4 from both sides to get to this line. Simplify to get to that line, and divide both sides by 2 to give us x equals minus 4. Example 4, slightly more involved again. So we have bases here of 9, 27 and 81. But look what we've done. We can use 3 as the base in each example. 3 squared gives you 9, 3 cubed gives you 27, and 3 to the power of 4 gives you 81. So here are all the indices. Now remember, when we multiply two terms together, where the bases are the same, we can actually add the indices. But before we do that, let's get to this line. There's your 3 to the 2m, there's your 3 to the power of 6, and that's 3 to the power of 4m plus 4. Now, as I was mentioning before, see those two bases here which are the same? We saw in an earlier video, when that is the case, you can just add the indices. So that's 3 to the power of 2m plus 6. Here we have 3 to the power of 4m plus 4. Let the indices equal each other. And some manipulation to get to that line. Further simplification to get to this line. 1 equals m, or m equals 1, and that's the answer. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle, what is the meaning of the following? Once upon a time. Now if you think about that, I think you might get it. It's actually a little bit tricky, but I think you'll understand it if you think about it. Here are the answers to the quick quiz, and the video is at your disposal. If you found this video useful, please subscribe on the next slide. You'll receive a notification when the next video is available. Please share with your friends. Hope to see you next lesson.